Okay, so lesson 48, derivatives of trig functions, which if you think about what we've already done at this point, derivatives of trig functions, we know two, right? We know the derivative of sine and the derivative of cosine. And I don't think we've learned any others. Correct me if I'm wrong there. Okay.
I'm just dying.
Let me know if you need something in the process of your death here. Okay, let's try to prevent that. Okay, so we know two basically. And what we're going to look at today is how we can use the derivative of sine and the derivative of cosine to find some of the others. Now, ultimately, long term, you're just going to want to memorize some of these others. And, it's not that, there are ones that we use on a semi-regular basis. And you'll just become very familiar with them as we go. Okay, but today is, okay, if you forget, say, the derivative of tangent, how could you find it? Using the derivative of sine and cosine. That's, it's kind of developing them. Long term, you'll just memorize them, I'm most likely certain. Okay? So, now, example 1, though. Use the fact that the derivative of sine x with respect to x is cosine x to find the derivative of cosine x with respect to x. So we're trying to find the derivative of cosine using the fact that we know the derivative of sine. Okay. So, we're starting with y equals cosine x. And our job is to find the derivative of cosine x with the fact that we know the derivative of sine. The direction we need to go here, do you remember your cofunction identities?
That's a solid. Like the cosine of
No. Cofunctions are the ones that use the pi over 2 minus x in them.
Oh, okay.
Oh, okay. So that's sort of like the cosine of x, or cosine of parentheses x minus pi over 2 or something like that.
Yeah. So what is the cosine of x equivalent to in those cofunctions?
Well, I know the cosine of x minus pi over 2 is
So the connection I need you to make, okay, and it's just one of those things you have to know. This one, you guys know these derivatives, but again, it's ways to how things relate. Y equals cosine x is our starting point. Well, equivalent to that, the cofunction of cosine x is equivalent to the sine of pi over 2 minus x. And it said to use the fact that the derivative of sine with respect to x is cosine. So we can differentiate right now. We can take the derivative, okay? And I'm going to use, when I take derivatives today, I'm going to use the dy dx form. So the derivative of y is dy dx. What's the derivative of sine of something? Cosine of that something. And then what else do we need to follow that up with?
times the derivative of something.
Times the derivative of that something. What's the derivative of pi over 2 minus x?
Or negative.
Pi over 2 is a constant, so there's no derivative there. The derivative of a negative x is negative 1.
Which is why it's negative.
Okay, so now, if we, how do I want to do this? I think I'm going to rearrange this and just put that negative out front. So dy dx, if I move the negative out front, it's the negative cosine of pi over 2 minus x. Well, what do you know about cosine of pi over 2 minus x? We're going back to sine of x, aren't we? Except that there's a negative out front here, which says it is negative sine of x. And of course, that again is using my cofunctions.
See, this is the cool part to me where it all kind of connects back.
Where it all connects back.
I just like to take it for it and go with it.
And that's, Two different styles there, right? I get it. There are students that are like, just tell me what to do, I'm doing it, whatever. And then there are the people that are like, no, I want to understand the whys. Ross, you're kind of in the middle. You'll do it if I tell you to do it, but you like to know the whys.
Well, then that's
But
physics became much more interesting towards the end of the year where everything started to connect together.
okay. So my summary statement here says the derivative of cosine x. So when I say d dx of something, that's saying the derivative of that. So the derivative of cosine x is negative sine x. That's what we just proved there. Okay? Okay. That was something you already knew. That was old news. Okay, example 2. Use the quotient rule. So it's telling us how we're going to do this, right? And the derivatives of sine and cosine to find the derivative of tangent x. So we are starting with y equals tangent x. Well, what do you think we have to convert this to based on the information they're giving me?
I know the tangent is sine over cosine, so you're going to have to do dy dx of sine over cosine of sine x over cosine
Yeah.
x.
They gave us a hint of quotient rule. They talked about using sine and cosine. What's the relationship between tangent and all of that? Well, tangent is equivalent to sine x over cosine x. So the idea that if tangent is sine over cosine, now we can take the derivative of sine over cosine to discover the derivative of tangent. So this is the long way about it for when you forget it. Just don't forget it after you learn it, right? So derivative of y is dy dx. Okay, how's this quotient rule thing work? Derivative of the top. So what's the derivative of sine?
Cosine.
Cosine x times the denominator.
Minus
And then quotient rule is a minus.
the top.
And now it's
The derivative of the bottom.
derivative of the bottom. What's the derivative of cosine x? Negative sine x times the numerator. All over denominator squared. So cosine squared x. Okay, we got it all? Cleanup time. What's that numerator clean up to be? Cosine squared x plus sine x all over cosine squared x. What's your pre-cal brain have to recognize?
So aggregate identity on top.
Yep.
So we go over cosine squared x, which is equal to secant squared x.
Okay, so Pythagorean identity on top. Cosine squared x plus sine squared x is 1. So we have 1 over cosine squared x. The reciprocal of cosine squared x is secant squared x. So now I have dy dx is secant squared x. And that right there is your typical derivative of tangent. What you should work on memorizing. Okay? And what I'm going to write over here is kind of my summary statement. D dx of tangent x. So the derivative of tangent x is what we're saying there. When you put that d dx in front, it's saying the derivative of tangent is secant squared x. Your choice in the future. Every time you use the derivative of tangent, do you want to have to develop it, or do you just want to memorize it? Okay? I mean, worst comes to worst, you can develop it. You can, know all that stuff. Okay, questions there? Okay. And so that was tangent. Is the next one cotangent?
Mhm.
Can you see the direction we're going with this one? No one seemed to have a problem with the last one, or if they did, they didn't speak up. So speak up if you have a problem with it.
I think it's good to list B.
But we've got the derivative. Use the quotient rule, derivatives of sine and cosine to find the derivative of cotangent x. So, starting with y equals cotangent x. What do we know about cotangent? Okay. So that is cosine x over sine x. We have a quotient now. So we can take the derivative. So the derivative of y is dy dx. Quotient rule. Derivative of the numerator, so derivative of cosine x, negative sine x, times the denominator of sine x. And then quotient rule always says we subtract derivative of the denominator. So derivative of sine x is cosine x times the numerator of cosine x all over sine squared x, which is our denominator. Okay, what about that numerator? Negative sine x times sine x is going to be negative sine squared x minus cosine squared x all over sine squared x. What do we have to do with that numerator this time? Factor out -1? Because if you factor out -1, then it'll be similar to last time, right? If you factor out -1, and actually I should just write that as a negative, not a -1. If I factor out negative, then I have sine squared x plus cosine squared x all over sine squared x. And for the same reason last time, sine squared plus cosine squared x is 1. So on top I have -1 over sine squared x. And what do we know about -1 over sine squared x?
Negative cosecant squared x.
What?
Negative cosecant squared.
Yeah. Still negative. The reciprocal of sine squared is cosecant squared, so negative cosecant squared x. My summary statement, if I can squeeze it in here, the derivative of cotangent x is negative cosecant squared x. Okay. Ready for example 4 when you are. As always, stop me if you don't like something I do. Okay, let's see. We are using the quotient rule and the fact that secant is a reciprocal of cosine to find the derivative of secant x. So we're starting with secant x. And what do we know about secant? Okay, it is the reciprocal of cosine, so secant is 1 over cosine x. And it said to use the quotient rule here, didn't it? So here we go with the quotient rule. Derivative of y is dy dx. Okay, quotient rule. Derivative of the numerator. So derivative of 1 is 0 times the denominator minus derivative of the denominator. So what's the derivative of cosine x? Negative sine x times the numerator. All over denominator squared. Okay, clean it up again. dy dx. What do we end up with on top? Okay, just sine x over cosine squared x. Now, this is not the form of the derivative we use. This is not the form of the derivative we know. So what I'm going to have you guys do is I'm going to have you split that denominator of cosine squared. And so I'm going to write this as sine x over cosine x times 1 over cosine x. So there's a sine x on top, right? Sine x times 1. My denominator, cosine x times cosine x, is cosine squared x. I didn't change anything, right? I just wrote it in a different form. So what are we going to call this denominator here, or this derivative here?
Would be tangent x times secant x.
Dy dx, sine over cosine is tangent x, times 1 over cosine x is secant x. So the memorized derivative of secant is tangent secant. So I'm going to say d dx, the derivative of secant x, is tangent x secant x. Again, my summary statement. Only because it's difficult, you get to the end, you're like, okay, the answer is tangent secant, but what did I start with? So I'm just trying to summarize it there for you. Okay. Example 5. We've got one left to do, right? Use the fact that cosecant is reciprocal of sine to find the derivative of cosecant with respect to x. So we want the derivative of cosecant. So y equals cosecant x, and so next we're going to say that instead of cosecant, the reciprocal, so it's 1 over sine x. And then we're going to, it doesn't tell us, but you know what we're going to do next, right? We're going to use the quotient rule. Derivative of y is dy dx. Derivative of 1 over sine x. Derivative of the numerator. So derivative of 1 is 0 times the denominator, so times sine x, minus derivative of the numerator, or excuse me, denominator, derivative of sine x is cosine x times the numerator. All over denominator squared. Okay, clean up. What do we have on top? Negative cosine x over sine squared x. Can you guess how I'm going to break this up?
Cosine x over sine x times
Negative cosine x over sine x times 1 over sine x. So basically just splitting that denominator, splitting the sine x up. And, yep, negative cotangent x, cosecant x. I'm glad I didn't waste my time going to answer the phone. Okay. So, summary statement here. d dx, the derivative of cosecant x, is negative cotangent x cosecant x. Are you seeing some trends as you went along this page? I mean, the derivative of tangent up top was secant squared. The derivative of secant is tangent secant, or secant tangent, okay? The derivative of cotangent was negative cosecant squared. The derivative of cosecant is negative cotangent cosecant. Now, at what point did you guys look at the next page?
I didn't know what it was, but I looked at the very end.
So, the next page is just kind of a summary of rules of where we're at this point. So yes, it includes the ones we just developed, doesn't it? So that's why, it's always interesting because some people look at the very beginning and so they kind of know, and some people don't look until the very end and are like, really? This was here the whole time?
Yeah,
So,
I thought of
these are just some basics, the derivative of a constant is 0. Oh, the derivative of a number times x is just the number. The fact that when you do the derivative of a sum, you just do the derivative of each piece. Product rule, doing the derivative of a product right here. This says, okay, keep the one, derivative of the other, vice versa. Quotient rule, okay, fancy way of writing the quotient rule. Derivative of the numerator times the denominator minus derivative of the denominator times the numerator over the denominator squared. Or what I call the power rule, when you have derivative of x to some power, move the power out front, subtract 1 from the power. Derivative of e to the x is e to the x. Derivative of natural log of x is 1 over x. Derivative of sine is cosine. Derivative of cosine is negative sine. And then our 4 newbies. Okay? So that's kind of where you're at of what you should be able to do with derivatives right now. That all should, be common knowledge at this point. Okay, so differentials, just a different way of writing all of those things, but still the same information. Okay?